YouTube. Okay.
Okay.
Hello. So we are back for this week. We will answer whatever we can. That is orally here. I did see that some of the questions, some technical explanations are required, which we will just post. If you post a question in the forum, I promise to answer that in the forum. Okay. If it's a technical question regarding the lecture notes, whatever we can answer over there, we will do that right now. But if it takes a big bit of explanation, we'll do that on the forum. That much is certain.
And regression tree question, for example, you can.
Yeah. So there is one very question about pruning regression trees. I'll just post the answer on the forum. I think it will benefit everybody. It's also easier to post the answer on the forum rather than explain over the video. Okay, so I just have to wait a little bit. I'll do it before the end of this week, so that shouldn't be a problem.
Somebody has asked about exam pattern. This will be basically all MCQs, multiple choice questions, some with one correct answer, some with more than one correct answer. We will concentrate probably more heavily on the deep learning portions. So, yeah. But the whole course is a part of this, except for week 12. Week 12 is essentially simply applications. So week 12 will be just applications of whatever we have done. Some people have asked about possible projects, etc. We'll be discussing that one whole week. So 4 hours of lecture approximately is going to be various applications of all the algorithms we have seen so far. Instead of doing it week by week, we have just collected it together so that you can see a full picture. Yeah. Any other question? Wait, if there are any questions, there's something else.
How many people are there in the forum?
31. What happened? Career options. Yeah, career options, etc. Wait,
this is okay. It's a reasonable question.
Yeah.
Yeah, if you want to pursue an MS MTech in the field of image and signal processing, I think in computer science parlance, it's known as computer vision. Okay, so signal processing again, the specialization is slightly different. So you have to decide whether you want to do signal processing or you want to do computer vision, because computer vision is a very hard research topic. Given that also many applications in deep learning are in computer vision actually. Would you advise me to go deep and learn more? It doesn't hurt for you to learn more, but eventually if you want to go for a degree, I mean, just apply for it and enroll yourself in a good degree program if you have the credentials to get into a good degree program. And independent study on your own is always encouraged, so it's not a problem. Learning through bagging implemented. So, okay, there is a question about, it's a very long question, so I won't read it out. So a question about I'll try to answer it in parts. How is learning through bagging implemented? See, the only thing, bagging is done so that you don't, to reduce the variance in binary decision trees. So binary decision trees tend to overfit. So there was a related question about pruning. Okay, we'll go into that. I'll post that answer in the forum. But for this question, because they overfit, we try to reduce that overfitting by fitting a lot of binary trees to the same data. I mean, ideally, you would like to have multiple collections of data into which you can fit individual binary trees and average the result. So that way, it reduces the variance in your output. As far as I understand, the only thing is bootstrap aggregation. Okay, so you have to randomly sample your training data with replacement, and then fit the decision tree like you usually would. Okay, so you fit multiple decision trees, and because each of these decision trees are fitted in parallel or independent, the data are fitted independently because the outcome of one is not dependent on the outcome of the other, or the input to the other. So you can fit them independently in parallel. So that way, if you are into parallel programming, the only technical problem there is how do you implement this in a parallel programming environment? Okay, so that is a technical challenge. As far as the splitting, pruning, etc., every tree is grown the same way. Okay, so whatever algorithms apply to a typical decision tree, also applies to the decision trees that are grown in the bagging process. Okay, the bagging is only for bootstrap aggregation of the training data. Okay, the binary decision tree itself, the algorithm itself remains unchanged. It's the same algorithm. Now, if you want to hack it, I think scikit-learn has an implementation of binary decision tree. You can actually go into it and see. I think the source code is available. You should be able to look into it and see how they've actually implemented a binary decision tree, how they do pruning and splitting, for instance. Of course, splitting the three algorithms, the three things I described, Gini index, or the entropy, or the misclassification is not typically used, but Gini index and the entropy are used. Split parameter is chosen. The split feature is chosen. So to summarize, in a typical iteration for bagging, the thing is bagging is only applicable to the training data. So you create multiple copies of your training data by bootstrap aggregation, and then to each training data set you fit a binary decision tree, and the algorithm for the binary decision tree is the same is the same for all of them. This is something we covered as if you do a single binary decision tree. Okay, I hope this helps. Thank you.
Building.
You want to answer it, or should we? So there is a question regarding unbalanced data. So actually, in a lot of the image processing tasks, except maybe for object detection, it's very difficult to say. For instance, if you're looking at medical image analysis, typically it's going to be unbalanced data. So there is going to be millions of pixels which are normal. There are going to be like tens of maybe hundreds or thousands of pixels which are abnormal, and there is always going to be imbalance. So there are many people give many solutions to it. One way is to do data augmentation. Okay, you collect a lot of one is, of course, you collect a lot of data so that you can actually balance data by sampling properly, or you do data augmentation. Either of those things you have to do to balance out the classes. Okay, so there are many approaches to it. Some people say you should not really try to explicitly do data balancing, because the real data in the data in the real world is unbalanced. It is not like you didn't sample it enough. So for instance, the example, if you're looking at tumor in a medical image is 3D volume. It has a volume of 256 cross 256 or 256, so the 256 cube. But your tumor you're looking at might occupy only like 240 cubed or 30 cubed. Okay, so that's a really orders of magnitude difference between the positive class and the negative class. Okay, but that's how it actually occurs. The data itself is like that. So sometimes data balance occurs because you are not gathering enough data for each of the classes. But in this case, many of the problems are naturally like that you don't have an option. You just have to work with it. Okay. One way to do that is actually, like I described in, there'll be one lecture where where we show how to handle it. You can weight the data differently. So for instance, the classes that have low occurrence, low frequency, you can weight them more in the cost loss function. So that way, you know that you are not biased towards one class.
One question: what career options? Where can I learn more?
There are more again similar questions regarding career options or where you can learn more. There are lots of courses online. NPTEL itself offers several versions of machine learning and deep learning, and a variety of other fundamental math courses and EE courses if you are interested in those.
And a lot of companies have now come up that with which if you do some certification courses, you probably are kind of guaranteed to get a job, etc. So yeah, so you can see there are I think literally if you put AI careers India in Google, you'll get a huge number of options.
Yeah.
There'll be good sponsored links also. So
yeah, some of them. So NPTEL is kind of free. You only pay 1,000 rupees for the registration, exam registration.
Yeah.
Actually, I mean, if you didn't know, 1,000 rupees you pay is not for NPTEL. It's for the conducting the exam. The people who conduct the exam get the money. So we don't so it's course is completely free. But there are those out there who are well intentioned. They offer you courses again with similar content, more exercises, etc. But they charge you a fee so that they can help you try to place you or find you other avenues for moving up. So,
yeah, typical course fees of such things can vary from anywhere from 30,000 to like a couple of lakhs.
Yeah.
So depending on the type of course. So you can take a look at that. IIT, of course, several IITs offer degrees, etc.
Several IITs have started masters in data science or AI or something, and IISc has one right now. You're free to apply to any of them and see whether you can get through.
So somebody is saying that I am working on statistical downscaling using deep learning. What are the limitations of LSTM for statistical downscaling in climate data? No, first of all, the statistical downscaling is a terminology which is used within the weather community. Just 2-3 days ago, I visited Indian Institute of Tropical Meteorology. So I kind of learned basically our multi-resolution problem is what they call statistical downscaling. You will see your kind of mixed techniques here. When you say LSTM is for time series data. This what I would recommend is you search for something called multi-resolution algorithms using deep learning. There are GANs algorithms. There are all sorts of algorithms which are there that you can combine to do some amount of statistical downscaling. Okay, so you can look at that. There are also other techniques called attention network, depending on what kind of data you want to assimilate, etc. That will be useful. But you will have to find out the corresponding terminology. Again, that was the hope within this course, that you should also recognize what terminology you have that the deep learning fellow will not recognize.
Yeah, exactly.
And how should you pose the problem? Okay, so the terminology we have used in all these weeks is what a deep learning person will use.
Yeah.
So you should be able to translate. Dr. Ganapathy will be teaching GANs the next week.
Exactly.
So again, so if you search, if you recognize that the problem that you have, for example, the statistical downscaling problem, is equivalent to a problem that, let's say, was there in CNN, use the CNN terminology, find out what that what that would be like when applied to your data. Okay, so you have to see the term that the deep learning community uses rather than your community uses. Somebody has asked about deep learning in bioinformatics. Unfortunately, we have no knowledge of bioinformatics.
Yeah,
we have knowledge only of deep learning.
Exactly.
So you will have to figure it out. I know that I'm not even sure whether protein folding falls as part of bioinformatics
or genomic studies.
Yeah,
I don't know either. In fact, I don't even know what they do there. So
so we are complete novices there.
Yeah, exactly.
So, but yeah, I'm sure that anything with bioinformatics, Google would have done something. So you can.
They have one. I did see that they have some open source version of bioinformatics package for deep learning for bioinformatics.
I think even MATLAB has something.
Yeah. So just explore those options. I mean, we can't really tell you exactly what to do.
Because we have no clue about the field.
Exactly. Yeah.
Is the PCA algorithm better than other facial recognitions?
Not really. No, we have, like you saw now, right? Face generation techniques with GANs are there, which give you lifelike images of people's faces.
But
and
PCA is just a.
There is eigenfaces one technique where they protect them. Okay. So yeah, eigenfaces works really well. That's one of the. I'm thinking that's the algorithm maybe you're referring to. That's called eigenface, I think. Yes, I mean right now I think a lot of deep learning architectures are around which will outperform that. But then beyond a point, outperforming that makes no sense. If the PC algorithm gives you 100% accuracy, and what's that outperform? Unless you are looking at something more computationally efficient. But then they would say the PCA would take lesser time than having a very deep network with a lot of memory. And
they might use PCA to get some early representations, and then you can still
train. Yeah. So as such, I mean, I have not actually done one study like that, but I would think that that's the case, that many algorithms would easily outperform PCA-based techniques.
So somebody has asked, as a beginner, should one focus more on ML algorithms or on deep learning? It depends on what you want. Deep learning currently is in vogue. Okay, so it's the current fashion. ML algorithms are more general ML algorithms are more mathematically sound, typically. But deep learning currently is in vogue, and often the packages that are there are such that if you understand deep learning a little bit, you can do a lot of stuff. Yeah. So it's just a balance. I would recommend that you study both. Deep learning has a lot of practical study. Other ML algorithms have a lot of theoretical study. So depending on what your strength is, please choose one or the other.
So I think both of them are required. So it's not like you can get away from ML altogether, ML algorithm altogether, because we have found that some of the so-called classical older ML algorithms actually work really well on many of imaging data. So it's not like you cannot abandon them altogether. So deep learning is in work. Finally, also many people are using it because they're easily implementable platforms are available for them. But then what you fail to see is that Even for other ML algorithms, Python codes are available, MATLAB codes are available. You can still use them. I mean, if the problem is like such that these methods give you better results, then it's obviously the best thing to do. Yeah.
Correct. Depends on the problem. So somebody has asked again, as a mechanical engineer, where should I start with machine learning in this course? That's where you should start.
Yeah.
But choose a problem that you want to solve. Ideally, that's the project that you would like to do. Mechanical engineering is a very, very broad field. You could be in robotics, you could be in thermal engineering, you could be in manufacturing. In each of these areas, actually, AI has been used for a long time. I mean, this is not new. So whatever techniques we discussed, you can try and experiment with them. We will start you off with a few problems. Some might be obvious, some might not be so obvious in the last week. Maybe that's a good beginning point with which you can think about other problems in your field. What are graph neural networks?
I haven't worked with them. I'll try to answer that question in the forum. I'll send you some links and maybe we can give a better explanation there rather than over the video. Okay. So, but in general, all that, if you look at the platforms that are used in deep learning, all of them interpret neural networks like graphs. So specifically graph neural networks, the thing is their input might be slightly different because you have to give the association between the inputs, not just raw inputs. For instance, you can't just give a picture as an input. If there are objects in the picture, one part of the input would be seeing let's say an adjacency matrix for all the objects in the input would be one input to a graph neural network. But that's a difference, I would say. But I can give you some detailed references or easy to understand references that you can go through on go. Yeah.
Which feature reduction techniques work well in images and videos? PCA or TSNE?
See, TSNE has a lot of hyperparameters to tune. Okay, so TSNE is more like a visualization tool. Of course, the underlying techniques you can use to pre-process your data. But right now, if you look at it, whatever I see so far, initially people are doing PCA mostly. Even for images, people are doing PCA. But slowly over time, people have just stopped doing that. The only thing they seem to do is like just normalize the data between 0 to 1 or within a pre-specified range and just give it to a very deep network. Okay, and then they take care of outlier pixels, things of that sort. So if you're looking at video frames or just images, just giving raw images as input seems to work very well. After, of course, normalizing the RGB channels. In fact, if you're doing RGB images, it's 0 to 255. You probably don't have to do much either. So you can just make them 0 to 1 and use them as input to the network. So my understanding is that TSNE or just visualization tools, again, they involve hyperparameters. And unless you know how to tune them, TSNE plots can also mislead you. So be very, very careful when you use TSNE plots. Okay.
In ENC, I suppose that means electronics and communication. Where is AI used? I have no clue, honestly. So because we are both not from that field.
Yeah.
But wherever you have manual input, there is always a chance to think of AI as a tool for automation. So wherever you are requiring people to use a lot of their judgment, you can always think about a way to automate it. So that is it. We are discussing a certain type of automotive, a few types of automotive models. There are general models, so you can see wherever it can be used. For super resolution problems, which algorithm works better? There is no such answer for any question within deep learning. For you will basically have to have, there is not one super resolution problem. It depends on what class of problems you are looking at. So you'll have to, when you search through the literature, I suppose you are the same person who asked about statistical downsampling. So you will have to see what looks most like your problem. So that is the best thing. If you are predicting rainfall, what kind of data looks similar to the kind of data that you are looking for which you want to do a super resolution. If you do super resolution with faces, you will see a certain kind of error cropping up. So you'll have to read the literature properly.
Exactly.
Again, the hope was over the last 10-11 weeks, you have got enough tools in your toolbox that you can at least read papers and understand what kind of techniques they're using. And maybe you are a little bit of distance away from implementing it, but with some time you can get that.
Yeah, super resolution, especially for RGB images. If you talk about natural images, there are several algorithms using encoder-decoder architecture. Again, the main problem is there is the what cost function to use. So, for instance, if you use a least square cost function, then getting a super, smoothing effects can occur and all that. So what people are working on, if you look at research, people try to modify the cost function so that you don't get smoothing effects or some other artifacts, like you said, might crop up, the kind of error that might crop up. So there are a plethora of techniques for that. Do a good literature survey. That's a way to go.
Somebody has asked which language is better for machine learning. We have answered this several times. Currently, the language that is being used most often is Python. That doesn't mean it's the best. There will be people, I am certain, who will be developing better languages.
Yeah.
People are moving towards something called Julia, but please do not chase the trend here. Please understand the algorithms better than the language.
Yeah.
The language is important for applying, of course. For application, it is important. But tomorrow the fashion might change. It's much better to understand how programming languages work. Yeah, currently, obviously, since the major frameworks are in Python, it's obviously essential for you to learn Python.
Yeah.
If I completed this course, can I apply for PhD in machine learning? Depends on which department you are applying in and which university. Actually, this course will not be used as a prerequisite anywhere. We also want to warn you that the assignments we have given and the exam also which we will be giving are obviously, we are constrained by the number of students writing it. It's a multiple choice question. We cannot ask complex questions. So answering these questions, even if you answer them well, doesn't qualify you to be an expert in the subject. Okay, that depends on how much work you have put in. Okay, please understand, we repeat this again and again. We have given only 30 hours of lecture.
Yeah.
And a PhD is, about 8,000 hours of work. So 30 hours obviously cannot be the fundamental for 8,000 hours.
No, exactly.
Okay, it depends on what you did behind the scenes.
Exactly.
So please talk to the university you are interested in going to, the faculty member you are interested in working in, and tell them what the background you have is. They'll ask you a few questions. That way you will know better about what you will actually need.
Just to follow up on that, if you look at the lectures, so for instance, even in CNN, I have covered some basic models, some advanced models. But there are many other techniques out there using CNN too. I have not covered all of them. And if I'll cover GANs, but then GANs has like several variants now. By the time we finish this course itself, there are several variants coming out already. And I'll just give you an overview of GAN. Same thing, like there's a student who was asking question about binary decision trees, how to prune. So for instance, I haven't taught you pruning binary decision trees. Okay. So, because generally, if you look at textbooks also, that is not a very well discussed topic. So they'll just talk about how to grow a tree, but pruning becomes a slightly more complicated topic. So I've also not discussed it in the videos. So which means that if you, again, though it means what I'm trying to say is your knowledge you have to complete. So like I said, there was a question about pruning. I said I will answer in the forum. That's because I want everybody to benefit. So I will answer that question in the forum. So like that, you have to raise some questions. You have to go back and read some standard textbooks and see what are the topics that you need to know more. So unless you have filled all the gaps in your knowledge of that field, you can never be too sure. Okay.
Also, just to give you an analogy, suppose you do first year calculus. Does that make you capable of doing a PhD in mathematics? It depends on how deeply you have done it and what the field in mathematics you are doing PhD is. So this is a fundamentals course. Like Dr. Ganapathy just said, we have now covered the basics. Out of these bricks, you have to make a building out of the whole thing. So depends on that. Okay, so you'll have to talk to people to find that out. What is the difference between AI and deep learning? Please watch week 1.
Exactly.
So we have discussed that there. How is NLP generated? NLP is not a part of this course. So you will have to do a separate course. I am not sure. There might be one within NPTEL itself.
NPTEL, there are several online.
Yeah, I think even Dr. Mitesh Kapra's deep learning course probably
has. Yeah. So Stanford has one and all that. Yeah. Many people are offering.
When did this course start? This course started January 28. So you can go back and look at this. What are the applications of Conan's self-organizing maps?
So self-organizing maps have been used in computer vision, pattern classification, things of that sort. It's a very nice algorithm. It was actually it has been very good applications. It's a good thing to learn, but I don't know. It depends on like I said. See, this field, some classical techniques that are like well established and proofs and all that. But when it comes to deep learning and a choice of algorithms, that's something you have to study on your own, depending on your data.
Yeah.
Okay. So feel free to pursue that. I know it's a it's a classic technique and it's a very fascinating technique also. Yeah.
Questions are more or less over. If there are no questions, we can probably move on. But just check. We'll wait for a couple of minutes. Just type. There are no session questions.
Yeah, so I will answer. I have given some token answer for graph neural networks. I'll send you references about that, and also on tree pruning. So I didn't cover pruning in the lectures, but I will either send a small note with a simplified version of how it works, and with a reference where you can read it up. Okay. So those two questions I promised to answer.
Jitu, you have asked, can you tell something about neural networks? I think you have not watched the videos so far.
Exactly.
So you have about 10 weeks of videos to watch. Okay, so please watch that.
Yeah.
So that's about 30 hours.
Exactly. I can do all of that in like 2 weeks. Yeah. I think you can ready to grade the exam.
Yeah.
8 hours, 4 hours a day if you watch, that's just like 7 days.
Somebody has asked, can you enroll in this course right now? No, not right now, but we will be running this course again, a slightly modified version in July. Yeah, hopefully a better version.
Yeah.
Because we made some, several errors in this course. At least in running the course, not in the course itself. Yeah. So we will change that, and you'll probably have a better version. Running from July to December.
Yes.
No, tell them that if there are no more questions, then we can end the session.
End the session, yeah.
Because there's only a small number of
people, 30 odd people. So before you sign off, any like detailed technical question you have, I appreciate you bringing those up. Those students who asked those questions, please post them in the forum, okay, and bring them to my attention. If it's not answered, I will definitely answer them. Okay.
There are some few questions. Do we have MATLAB exam access in the exam? You will not require it. You will not require it. You will just require pen, paper, and if there is any calculation required, a calculator will be provided to you, just like the GATE exam if you are used to it. Basically, a computer-based
test.
Test, and you will not require too much of calculation. It's not calculation heavy. This course title, ML for Engineering and Science Applications, but how is it different from other courses? We discussed a few applications before, and we will be discussing a few more applications in the 12th week. Earlier, the plan was to spend each week some time in some application, but it was not working out for us logistically. Maybe the next version we will do that. But anyway, you will see a large number of engineering and science applications in the last week. That's about 3 to 4 hours of content. Are there any websites which give some examples of how to code simple neural nets from scratch? I'm sure if you write literally this on Google, you will find a few places.
Yes.
With some GitHub links, and you can probably see this even within YouTube. Yeah. So I'm sure
many online courses also allow you to program them, so it should be there. That's it.
Difference between contractive autoencoders and denoising autoencoders. These are very technical questions. Please post them on the forum.
See, I haven't done autoencoders yet, so wait till next week. Next week's forum, you will have the opportunity. Post it in that forum, I'll answer it. I'm not covering contractive, I'm just covering denoising autoencoders or regular autoencoders.
Yeah. Somebody has asked what modifications and changes, just in terms of order of how we have covered the topics, whether we want to put applications right in the middle, whether we want to add some more Python code to the MATLAB code that we showed, stuff like that. Okay, just making the course a little bit more coherent, a little bit tighter based on the feedback that we have got so far.
Some lectures we redo. Those things.
So
I mean, machine learning doesn't change that drastically.
We are not going to add too much more content. Will there be negative marking in the final exam? I am not sure. I don't think so.
We don't think so. We don't know. Actually,
I don't know. But we will confirm it, and it will be posted on the forum. If there is a general policy that is there for all NPTEL exams, whatever it will be followed. My guess is there is no negative exam marking.
Probably not. I think GATE has it. I don't think this has.
Somebody has asked brief overview of graphical models. I'm sorry, that will be probably too much.
We
had initially planned to do that.
But
the time in this course is too little, so we will not be able to do that.
But there are good probabilistic graphical models course separately available. Please look for them. I mean, not only the NPTEL, I'm sure somebody has done
it.
Coursera has it. Some other sites also have it. Please go through that. It's fine. I understand, but we can't There's not enough time. I mean, the background for that will take a few weeks. So then we're out of more than, actually even now we have done more than 30 hours, I would believe.
Yeah. How do we learn machine learning algorithms easily? There are no tips. If it was easy, I mean, I think as we have presented it is probably the simplest form.
Yeah.
But the simplest form can often be misleading. My again recommendation to you is it depends on what you want to do. Do you want to get a job? Do you want to apply it for your PhD problem, etc., etc.? Depending on that, it is much better to go back and forth between whatever you want to do and whatever we have taught.
Exactly.
If you want to write a code, write a code. Let it go wrong. Check for tips. Come back to this class. Maybe you're making a theoretical error.
Yeah.
Or maybe you're making a coding error. It's usually, unfortunately, anything practical is a mix of 3-4 things. The theoretical thing, the coding knowledge, and how good you are at debugging, etc. It's a mix of those things. So depending on what you want to do, you will have to actually iterate. There is no shortcut.
To add to that, there was a question about, talk about the details about, there's a software programmer who was asked the question regarding binary trees. You realize that when you start implementing it, there are lots of these little hyperparameters, things that you have to code, which we have not talked about, right? We've only given you the general idea behind the algorithm. It's like do a split on this information criteria. Then how do you implement? So for instance, you have to 10,000 features. When you have to see information gain for each of them. So how do you parallel program that? That part we haven't taught. Okay, so that's something you have to figure out. I mean, for a parallel programming course. So, yeah.
What is the next step after this course? It depends on what you want to do. This is just a foundation course. It's a very, very basic foundation course. It's not an advanced course at all. Even though we have covered a whole range of algorithms, next step is whatever you want to do, you will actually have to try and implement it. If you want to, like I said just now, if you want to get a job in a particular company, find out what kind of skill sets they are looking for. Maybe that you have to do some amount of data reading, etc. That those will complement whatever we are doing.
Exactly.
Do make sure that you can write some practical codes. Exactly. That would be the first step, I guess.
Actually, the Kaggle website is very good. You just enroll there and try out some of the problems there. That's something we have said in the past. It's an excellent resource for people who want to be a data scientist or even be a deep learning expert. You can check out, you've already solved problems. Try and do it on your own. Check what others have done. It's a good way to get some experience.
How do you detect outliers in a data set?
See, there are many ways of doing it. I mean, do you want a machine learning algorithm or you just want to see? Well, it's practical thing, right? You can just fit each of your features to a Gaussian, throw away things that are 2 sigma away.
Correct.
That's or just see how far it is from the median. All those things you can do, right? I mean, there are many techniques. Once you so you can throw away the outliers like this. And if you actually want outlier detection algorithm, there are many. I mean, we haven't covered it specifically, but there are many ways of doing that. An autoencoder is one way of doing that, actually, to detect outliers. There actually there's something called isolation forest. I think that also detect outliers. I mean, there are many ways of doing that. So, yeah, but the simplest way is fit a Gaussian, see how far away your data point is from the mean. If it's 3 sigma away, probably it's an outlier. Okay. Is it done? Are we done?
Some more questions.
How many people suddenly? So that 31 still asking. Okay.
Somebody has asked, what research topic did you do in PhD in machine learning? Neither of us did our PhD in machine learning.
Yeah.
I work in computational fluid dynamics. Dr. Ganapathy works currently in
medical image
analysis. Both of us have used machine learning. Our PhD students are using machine learning in their respective PhD problems. Machine learning has come to a place where it is broadly usable, especially deep learning, in the last 5 years.
Yeah.
So we did our PhDs way before that.
Yeah, that's true.
Yeah. I am asking a question from V8. You have explained number of parameters for LSTM and vanilla RNN without parameters. I can get that. Whereas for bi-RNNs, you have included biases. Am I understanding correctly? I think you are probably saying that the expressions that I wrote for LSTM, I wrote them without the biases. I have in fact mentioned it. just for simplicity, whenever I write something like, W times H plus U times X, I am explicitly removing the bias there. I had mentioned it once, but I didn't mention it again and again. And you're right that probably when I wrote it for bi-LSTMs, I might have actually included the bias explicitly. But you know from the previous lectures that whenever you write a neural network, you should include the bias term. So if I have, layer A going to layer, or layer L going to layer L plus 1, in between these two, you should add both W times whatever is there in the hidden unit there, plus a bias. So that bias should always be written. Sometimes we eliminate it. In LSTMs, it's a standard notation to not write it out, but you can include it. Okay. Or like we had discussed earlier, in the weight matrix itself, you can add one set of W zeros, and within the vector itself, you can add a 1 at the top, and that will automatically give you the bias. So that notation we have gone back and forth even through the neural network lectures. In practical problems, are we supposed to reduce accuracy of the model to accommodate the outliers? Depends on the problem. Depends on the problem. In certain cases, it might be a bad idea. Certain cases, it might be a good idea. Certain cases, it might be a good idea to put different models for the outliers and for the main data. Accepting these as, you could probably cluster and then put two different models, one for outlier and one for normal.
Yeah, the best way is to look at different forms of the loss function. So you have seen the lecture. The least squares loss function is often used, and that's because that comes from the Gaussian distribution. There are distributions which will model outliers much better. You can use that as a form of the loss function. And most of the time, you're only exponential loss functions because it's very convenient to use them if you take the log. But there are other. We should look them up. There are lots of them in literature.
Which subjects are important for machine learning? I don't get the question. If you're asking for prerequisites are mathematics, linear algebra, probability statistics, multivariable calculus, programming. These are the prerequisites that are important. If you know these well, then you can do machine learning reasonably well. Otherwise, current fashion is deep learning. We don't know what future fashion is going to be. Okay, it might be something else. So over the last 2 years, it's GANs.
Yeah, I know.
Yeah. So now, you ask me this next year, we'll be saying deep learning itself is out of fashion. Yeah. So we don't know. So importance should be given to the fundamentals, which is what we have kind of given here. It's been an overview course. Which ML algorithms are suitable for a software engineer? I don't get the question. If you're a software engineer, then programming is very important for you. That's about it that I can, in my great knowledge, that's about all I can say. But I cannot see something specific which is important for software engineers or unimportant. Depends on what you want to apply it for. Do we get similar conceptual questions in the exam? You will get. It's a vast field, yes. That's why we had to cover a lot of ground through this course, which has led to difficulties. We do not know of any other comparable broad course which exists. And all the techniques that we have discussed have been used in one way or the other in several engineering problems. Again, maybe next version of the course, we will probably show one for each one. Exactly. If we have the time and if we can make our lectures a little bit more compact. But concept, as far as the exam goes, yes, you will be asked conceptual questions more than calculation questions. About 50% of the paper would be somewhat similar to the assignments.
Exactly. Yeah.
The rest of it would be still similar, but it is not going to be, you can't just answer just based on the fact that you answered the assignment. You should have thought about the subject.
Exactly.
Yeah. But it's not a very hard exam, honestly speaking.
Yeah, exactly. Yeah.
We could have made it much harder if it was subjective. Since it's objective, there is only a certain level of difficulty.
Yeah, MCQs. The only thing you have to watch out for, some questions have multiple right answers. So just pay attention to the choices and, tick up the right boxes. Check off the right boxes, whatever. Yeah.
When I try to implement and create my own CNN, an error occurs. The output of layer 4 is incompatible with the input expected by layer 5. Okay, how do I debug it? How to get into the network layer? I don't think you need to get into the network layer, but you need to know what parameters you have given, what the size of the layer 4 and layer 5 is. You should be able to see the lectures.
Yeah, and see.
Yeah, actually, it might be a good idea to give some such exam
question. It's a good exam question you just gave us, right?
Yeah.
No, but it depends on what is there a TensorFlow error? That's not how it comes out. Or?
No, I think it's just not compatible. Yeah, the filters here and the number of layers, etc., might not have matched. So please look at the lecture. You will know that how the output of one layer is supposed to get, what all supposed to match.
Yeah, exactly. I think there was one MATLAB code I had, and you should just look that up. You should look that up, where I just have several layers listed out. I think all kinds of layers were listed out in that particular example. You just go look it up, and I know MATLAB help like doc, and that command name will show you what each of the parameters are and how to set them. Just run the example first, try to modify the examples, then you'll be able to see. If you're using MATLAB, that is. I mean, I'm assuming, but or for that matter, any other platform, run that tutorial or example codes and modify them actually. That'll be a good exercise to do.
So this course's certificate help us get a job? No.
We answered that last time.
Answer is no. Okay. So unless, at least I don't know of any job which will ask for this course's certificate.
Yeah, exactly.
NPTEL certificates are, I think they are more academic certificates than anything else. I'm not sure, at least. I am not sure. Maybe NPTEL offices.
These questions are best directed to NPTEL directly. Like as course instructors, we only deliver the material. We do not interface with companies or anybody or recruitment agencies or anything personally. So NPTEL office would answer those questions much better. So write to them directly, ask them what they think about getting you a job and things like that. Okay, only they can answer that question.
So somebody has asked for solutions of the later weeks. Yes, we should be posting it. We should be posting it soon. What is the exam name? I'm not sure what they must be the same as the course.
Same as the course. They are very strict about that. You will let to know. Yeah.
Will GMMs be explained? Yes, that's the plan. Week 12, we'll have a brief GMM session. The only problem right now is just to explain it might take too long and it might go above and beyond the applications portion. If that happens, then GMMs will not be explained. Otherwise, they will be.
I think we are already overshot. I mean, we are supposed to do only 30 hours. I'm pretty sure right now it's going to add up to more. So,
So somebody Adarsh has explained somebody else's error, saying it could be possibly because of dimensions of output and the input of the next layer do not match. Yeah, that's what we were also saying. That's correct. We agree. Some examples for decision trees and ADA boost.
Okay. I will specifically see. One thing I will do that. I'll find some codes or I'll ask my TAs also to see if they have also come across it. We have a paper ourselves, and we have used the I think a random forest in that paper, as well as the naive based classifiers. So we have done a walkthrough. It'll be that video will be posted sometime next week. So then you'll be able to look at it. We have our own code out there, which you can see. Otherwise, the good resource for this, there are 2 textbooks, Elements of Statistical Learning and Introduction to Statistical Learning, the ISLR and ESLR. I think they both have a lot of data sets which you can import and maybe try. It's in R, but that's okay. That shouldn't stop you from experimenting with them. Otherwise, I will try to find some data sets that you can play with Python, in Python, using scikit-learn or some other packages.
So do you plan hands-on machine learning? Teaching hands-on machine learning, probably within the NPTEL thing, it can't be done very well. Exactly. So we might actually post videos on our own website. So if you are interested, we'll probably post a link so that whenever we post videos, you can keep track of that. So we'll probably post a Google link for those of you who are interested in keeping track of that later on, maybe next week.
We'll just do that.
We'll just post a link on the forum for those people interested, because within this we can't test it, nothing can happen. So that's not a very useful course to have on NPTEL platform, but probably individual videos we'll post on our individual websites or YouTube or something. So if you want to be informed, we will just post a link. So you can sign on that. What is machine learning for fresher? That is this course.
This is really for fresh people. We don't know. See, whether you have gained from this course or not, if you want to figure out, just rewind, do a flashback 12 weeks ago, and if you knew nothing and now you know something, enough to ask me for an example for a binary decision tree and about pruning and all that. So yeah, definitely you have gained from this course. So this is for the freshmen, yes. Yeah.
What are the number of parameters in 3A for Google Net in week 6? It was evaluated wrongly. I think this was handled.
Yeah, this was handled. Yeah. All errors until week 6 have been handled. Yeah.
I think probably the question, we had posted it right, and the paper itself had mistake.
Yes. So what Balaji said is right. The Google Inception's paper had an error there. The number of parameters, not exactly error. I think I think the understanding was they had divided the number by 1024 and then said some. So when they say 10K, it's 10 times 1024, something like that. And the answers we had provided are actually correct. So we verified it. So there was no problem with that question, except that it was different from what was in the paper, but the paper was wrong.
So somebody has asked about expediting the transcript process. As we said the last week, it is out of our hand. Somebody else prepares the transcript and sends it to us. Our students actually spend many hours in cleaning it up.
Exactly.
And this process actually takes a lot of time at our end. Unfortunately, transcripts after week 1 have come only now.
Exactly.
Okay, yeah. So our students have their own full-time jobs. They have PhDs to graduate from. So they are doing the best job they can. So unfortunately, it will take as much time as it takes.
Yeah. See, the problem is, the NPTEL runs like hundreds of courses in parallel. Okay. Yeah. And there are not too many vendors out there who will
so do there's a bottleneck on their end also.
They can't give it to anybody. They have some trusted people they give it to. And it takes time for them to go through. Some of us speak fast, some of us speak slow. There'll be errors in our pronunciation, all that. And then it comes back to us, and then we check it one more time. And
the mathematics has to be fixed. All sorts of issues are there.
So we are fixing it, and you will get all of the transcripts.
But no, since they want it before the exam, I know that it is easier for you to review if the transcript is there. But nonetheless, unfortunately, and I agree that even I would have preferred a transcript over a video. Okay, but currently you are stuck with the video, and please run it at 2x or something and hear it out.
Multiple times.
Jump to portions if you find it very boring, just jump to other portions and see if it works better for you.
If you are interested, you can provide some of the transcripts yourself. Post it on a forum just for everybody's benefit. That's also good for you'll learn better. Yeah.
Somebody has asked, this is a good question. Should you try to implement algorithms from scratch, or should you use something like sklearn? It depends on why you want to do it. But maybe once you can try and when you have 6 months in your hand, you can try and Prof.
Do back Prof. Right. In fact,
beyond joking.
Yeah. Write matrix multiplication from scratch. In fact, what best algorithm for you to really test your programming chops is figure out matrix multiplication.
Yeah. With parallelization.
With parallelization, do that.
Yes. But backprop is notoriously hard to program. People here, there is a very good course by Professor Balram and Ravindran where students are, or even the deep learning course by Dr. Mitesh Kapra, where people are given this exercise of having to program backprop. It takes a long time.
Yeah.
So maybe once in your life you can try and program it from scratch in order to understand what's going on. It's a good algorithm but what you will learn there is programming.
Exactly.
More than anything else, and you'll get confidence in your own programming skills. But otherwise, it's always a good idea to work at all levels of the pyramid. Try and implement something immediately, which will make you know what all algorithms are already programmed and how they work. Yeah, so I would recommend both actually.
It depends on what level you go to, right? Exactly. Because many of the numerical algebra routines are already there. Many even the software packages that you use, they use some of the numerical algebra routines which are like actually available for free and pre-compiled and all that. If you want to program those, that's also very challenging. Like for instance, like I said, matrix multiplication or even gradient descent from scratch, these are very challenging things to do.
Scalar is 10 times faster than Python. Then why are many people preferring Python? Because Python has many other things that it can do other than Scalar. People would like to shop at one place, so to speak. Like people go to Big Bazaar and shop rather than going somewhere else. Yeah. So it's just easier. As somebody pointed out, if it is sklearn or if it is Keras or anything else, there are a lot of things ready-made available to you. It's like fast food. You use it even though normal cooking food is healthier.
Exactly.
But Python is currently the fashion. Tomorrow it might be something else. It's not necessarily the fastest thing that will work out. You will have to program everything from scratch, back prop from scratch if you are using Scalar. Why would you want to that? It's faster after it runs, but you have to program also. No, that much overhead you will have to give.
It depends on what your aims are. Like, you always keep in mind what you're looking to do. If it's the application you're trying to solve, or are you trying to learn programming? Or you're trying to, are you aiming for an efficient implementation of a binary decision tree, or are you trying to solve a problem using binary decision tree? If the problem is, the solution to the problem is more important, then you don't have to worry about these things. But on the other hand, if an efficient implementation is, then you worry about it, then you learn. That's a different thing altogether. Yeah.
Deconvolution and backward convolution are the same. Are they the same?
No, deconvolution, it's a bad terminology, because deconvolution is used in image processing, signal processing literature in a different sense. It is trying to recover the original image from the blur. So what we typically people use, if you really want it in a very simplified way, think of this transpose convolution as some form of upsampling or interpolation. Okay, that's the way to look at it. I mean, that's like I would say that's the correct way to look at it. Okay, the process itself, the actual computation, is implemented in a certain way. Okay, so, and for reference, you can look up the paper that I posted, very detailed account of all the computations that happen in the CNN. That also includes transpose convolutions, and how that upsampling can be represented in the form of a convolution is what that paper describes. So that's all it is. And I think, but the best way to think of it is, it's just actually an upsampling operation. That's what you're doing. And but upsampling, there are established techniques, for instance, bilinear interpolation or trilinear interpolation or spline interpolation. Here you actually learn the coefficients of the interpolation rather than fixing them. That's the way to look at it.
Is there any connection between Java, C++, and machine learning? I didn't get the question. I am assuming that you are asking whether Java and C++ can be, it's any programming language can be used for machine learning. C++ would be faster than Python, but unfortunately most packages exist in Python right now.
The cafe is implemented in C++. So if you like that, but then it has a lot of you can't do everything in it, and if you want to do it, you have to prove a lot of programming yourself. But it's a very efficient implementation of deep learning algorithms in C++.
Suggest ML topics for PhD. That's too broad. That's like saying ML topics or mathematics topics for PhD. It's very, 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 very broad. So you will have to talk to the person you are interested in working with, or talk to the university that you are interested in going to, because obviously PhD is not something you do on your own. So go and talk to people that are working in that area, whom you are interested in doing a PhD with. They will suggest some topics. What is the significance of feature selection in machine learning? Why is it generally overlooked in practical applications? I don't think it's overlooked.
Yeah. That's what people focus on heavily, I think, in any application. Nobody overlooks it. It's said that they don't address especially as feature selection. See, for instance, L1 regularization is the same thing as feature selection, right? Because many of the weights go to 0, which means that you're only assigning weights to the most prominent features. So it's there always. It's just not explicitly called as feature selection, but it is the focus of most algorithms. And that's what we do. Same thing with drawing binary decision trees.
Somebody wants to, so which jobs are there for machine learning in the market? I do not know, but currently the market is huge as far as we understand it. It won't be especially for, there is this data analyst / machine learning, etc. So again, you will have to decide on what market you are looking at. Are you looking at it in financial sector? What are your expertise? One thing that I would strongly recommend is, whatever, if you have some domain expertise, that plus machine learning can be a powerful combination.
Exactly.
You have to have at least one other skill set. If you are still a beginner, have at least one other skill set other than just machine learning. So then you can show a powerful resume. This is the same. Somebody has asked for MS abroad. First, my question is, why MS abroad? Why not here?
Yeah, exactly.
Okay, so there are sufficiently good people within India. There are multiple places that are offering good MSs. Why would you pay your way? And if you have so much money to spend, then there are other better places to give them off to.
Exactly. Your own bank account, for instance.
So don't do. So you can do a PhD abroad.
Yeah,
if you are just looking for an MS, there are very good places within India.
Yeah.
You can go to IASC. You can go to any of the IITs. ICERs are there. Wonderful places are there.
ISI, a lot of places. I mean, every place will have at least 2 or 3 faculty working in that area.
Yeah.
There are hundreds of vacancies there. I mean, I think I think you're just doing a mistake by going abroad.
Then there are no special techniques by which, even if you are planning to go abroad, though we prefer that you do something in India, at least that's our advice. What should you do to make your resume look good? I mean, just do a lot of work. Do a lot of coding, post it online, post your code online on GitHub, put that as part of your resume. Then people can evaluate your skills based on something practical. Solve a problem, put it online. Put a YouTube video, put a blog, etc., etc. So all these things are there. Yeah,
I think we should go. I mean, we're done.
Thank you.
Time's up, guys. Thank you. Yeah, we'll see you next week. Possible.